You know what's really interesting? Earthquakes. When an earthquake occurs, the ground moves in two very specific ways. The ground will move side to side, and it will also move up and down. First, let's consider the side-to-side motion. These are compressional waves. Geologists refer to these as P waves. These waves can be detected with a simple pendulum. The pendulum hangs in equilibrium. When an earthquake occurs, the ground moves side to side, but the pendulum, due to its inertia, remains fixed in place. By attaching a pen to the bottom of the bob, we can record the side-to-side motion of the ground by pulling a piece of paper across the path of the pen. The more the earth moves, the bigger the amplitude of the drawing that gets recorded. The ground can also move up and down. These are transverse waves, called S waves by geologists. A pendulum can't measure the up and down motion of the earth, but a mass hanging from a spring can. As the earth moves up and down, the inertia of the mass keeps it in place. If a pen is attached to the mass, the up and down motion of the earth can be recorded on a paper that is dragged past the pen. These two devices working together can record all the seismic motion of the ground. Here's an actual setup of a working seismograph. The speeds of the S and P waves are very well known. When an earthquake occurs, a detector will sense the S wave first and then the P wave. You can tell how far away the earthquake occurred by the difference in the arrival times of the two wavefronts. One detector station cannot tell you where the epicenter of an earthquake was. It takes 3 detectors working together to pinpoint the epicenter using an intersection of the data as a locus problem.